In this video, we're going to look at topic 73, example 4, simplifying a quotient with complex numbers. In the previous video, I mentioned complex numbers where we had this 3 minus 2i and 3 plus 2i. And what they were useful for is to kind of eliminate the complex part of an expression. And you won't always completely cancel it out. You'll see that in this video, but we want to kind of go from there. So the concept complex conjugates are complex numbers with equivalent real parts. So equivalent real parts being like 7 and 7, or -2 and -2. And then opposite imaginary parts. So opposite imaginary parts would be -8i, +8i, +i, -i. And their product is a real number. So they do kind of the theory over here, where you have a plus bi and a minus bi. Notice that a and a are the same, but positive bi and negative bi are opposite imaginary parts. And when we FOIL or distribute this all out, you wind up with this I squared. Your 2i squared becomes this -1, right? And then your two middle pieces, these two, cancel each other out, right? They're eliminated, so you wind up eliminating that complex number, and then the I squared becomes a -1, so you no longer have any complex numbers involved. So let's kind of put that in practice, and when would this be useful? When we're looking at quotients, division or fractions, what you're really not allowed to have or not supposed to have is you're not supposed to have a complex number in the denominator. Okay, so we don't want to have this I in the denominator. It's just not the proper way to write a quotient or a fraction, however you want to look at it. So what we can do is we can use the properties of complex numbers, complex conjugates, to eliminate that I from the denominator. Now you'll see that the I kind of goes up into the numerator, which is fine, that's allowed. We're just not really allowed to have it in the denominator. So to rewrite this, you take your original expression, and what you're going to do is you're effectively going to multiply by the number 1. Except instead of multiplying by 1, I'm going to multiply by the complex conjugate of my denominator. So 2 minus I, I'm going to multiply, I'm going to put that in parentheses, I'm going to multiply by 2 plus I. I want the opposite imaginary part. So the 2 stays the same. If it was a -2, I would leave it alone. I would still use -2. I just want the opposite imaginary part. And since I want to multiply by 1, because I don't want to change the actual value, I just want to change the appearance, my numerator is going to be the same thing. Right, so if I take any number, 18, and I multiply by 1, it's still 18. If I do 5 over 5, well, 5 over 5 is 1, right? So I still get 18. That's what we're doing. We're just kind of being sneaky using complex conjugates, multiplying by 1, and that'll eliminate the complex part in the denominator. So up top, you're going to take that 10 and distribute. 10 times 2 would be 20. 10 times I would be 10i. In the denominator, we're going to multiply everything out. 2 times 2, use your FOIL method, you get 4. 2 times I would be positive 2i. Negative I times 2 is negative 2i. And negative I times positive I is negative I squared. Okay, remember that I squared. What am I trying to write here? There we go. I squared is equal to -1. So keep that in mind. I'll keep reminding you of that. The numerator, we can't do anything with that, so that's just going to stay as 20 plus 10i. The denominator, the 4, comes along. These two middle terms are going to cancel out. That's the whole point of using complex conjugates. And then we're going to subtract -1, because I squared becomes -1. Keep going, right? We have like terms. So 4 minus -1 would be 4 plus 1, which is 5. A lot of times you would be done here. In this specific problem, we can simplify this. We can reduce. Everything is divisible by 5. A lot of times you will be done. for this case, divide everything by 5, so this would become 4 plus 2i. And that would be, and it's in our complex number form, right, a plus bi. So that would be, I don't want to call it the solution, but that would be the form a plus bi, the quotient in that form. Again, there's a good chance you wind up stopping at this step here, just because things won't always reduce out very nicely. But if they do, you definitely want to reduce them. And we have our answer, what we're trying to do. So try it 4. You're doing the same thing. You're multiplying by complex conjugates. Remember, you're only changing the complex conjugate, the opposite imaginary part. So for 2 minus 6i, that 2 stays the same. Instead of a negative 6i, you'd be using positive 6i. And in part B, I'm going to kind of help you out here with this one. Your denominator, the negative 1 stays the same. You want to change the complex number part. So instead of plus 2i, you'd use minus 2i. Your numerator is fine. You're not going to change anything about that. We can leave that I there. We're still going to multiply by negative 1 over negative 2i. Sorry, negative 1 minus 2i. Because we want that to be the equivalent of 1. You use the conjugate of the denominator in both the numerator and the denominator. Hopefully that doesn't confuse you. These will take a little bit of practice, but you will get the hang of them.